those of you who did not attend class today, I profusely apologize for not recording everything up to this point. Okay. Well, still a lot more to cover, but so what you can see here are several graphics commands. This is actually what you see here is everything I've done up to this point. So just as a quick recap, how I created a vector of equally spaced x values and plotted y equals x squared. X is a column vector. Sorry for those of you who are boring by repeating this. So to square element by element, you must use a dot exponentiate, not just exponentiate. Use a plot command to plot y versus x. Ignore this was my mistake from earlier. You can use these commands to label your axes. Any plot command will wipe out the results of the previous plot command unless you use the hold command. Here I'm using hold on to indicate that subsequent plots will be superimposed. So now I plot cosine, but using black circles. Here I'm using a red dashed line. That's how you change the appearance of your curves. But here we had too many points. There's actually roughly 2,000 points in this vector, of 2001 exactly, actually. So now I create another vector equally spaced x's with fewer points to show what's like to plot a curve with, actually, I can show you what the results of my latest plotting command. So this is plotting cosine x from -1 to 1 using black circles. And then then use the title command to do the title. Hold on. So then I can plot function y equals x, so x2 versus itself, using a red dash curve. Legend is used to label the curves. And then gtext is used to place a text label anywhere you want in the graph. I issue this command, and then you can point to whatever, click on whatever point you want to place the text, and it will place it there. And now you're as caught up as can be. Now, the figure command, if used by itself, creates a new figure window. Notice here it says figure 1. So the figure numbering is important. If I do figure with no arguments, it creates a new figure window. Notice it's figure 2. So that's the default behavior. It'll just take a first available figure number. Or I can specify the figure number with an argument. I can do figure 10. And that will create a new figure window. Label figure 10. If you give it a figure number that already exists, it will just make that figure be active figure for subsequent plotting commands. It will not wipe it out if there's already something there. Now, another useful command is subplot. Subplot's used to put several sets of axes in the same figure window. So I'll do it with this figure 10 right here. So this command, subplot 2, 3, 1, what it does is it makes a 2x3 matrix of axes. And then the third argument indicates which one is the active set of axes. The first one. They're numbered by row. So if I do this, and I go back to figure 10, so this is the first set of axes. So it's a 2x3 matrix, 2 rows, 3 columns. So this would be 1, 2, 3, and then 4, 5, 6. That's how they're numbered in what's called row major order. So now what I can do is I can plot something in this set of axes. I'll just plot the exponential function. Let me see here. And now I can make another. Same matrix, 2 rows, 3 columns, but I want the second set of axes to be active. Oh, I had the wrong. Well, good thing I didn't need this figure anymore. I wanted to go in this figure. So I click on it, that makes it active. And there it is. So then subsequent plotting commands will go in here. Now, I want to show you something that I did in this class several years ago that made heavy use of the graphics capabilities of MATLAB. And hopefully I can find it without too much difficulty. And I'll post the code. Okay. Okay, I'm going to close all the figure windows that I currently have going. Close all will do that. So now there's a function here called MathDance. And I want to show you its inspiration. Okay, this is the one I'm thinking of. Yeah. So, all the different functions that the answer is simulated here. Not sure about this one. But, so, a student made some remark that inspired me to try to recreate this in MATLAB. And so I had some fun with it. And please let this work. Okay. So I'm specifying certain built-in functions. And then I want to give them labels. I ran this not too long ago, so it should work. Okay. Now, after getting the graphs working, I don't know if you can see it very well, how the eyes move from side to side and are red, and some students thought that was a little creepy. But you can make things even creepier by selecting different functions. So here it's this sine and cosine, which is pretty innocuous. But now suppose I choose different functions, like tangent and the exponential. So you can see the vertical asymptotes of tangent, and then the exponential, he gets a really long arm. So, but only his left arm. So
you just like plot like a generic circle function and negative x squared?
Yeah, I use polar coordinates. So what I do is I have a vector of theta values, and then I use polar coordinates to plot the head and the eyes, also the lower half of the mouth. I used a 4th degree polynomial for the torso. I wanted to have a somewhat flat curve over here, like on the shoulder. And then whatever function is provided, I evaluate the function for the arms. And then I multiply the y values by scaling factors from like -10 to 10 to make the arms go up and down. So also notice here I have y e to the x. The x is superscripted. And I mentioned that there's a primitive LaTeX interpreter. I did e up arrow x. So that implements a subscript. So it took some doing to make this happen, but I will post the code so that you can play around with it yourself.
Is it hard to? Did you have to keep playing around and get the arms and stuff in the right place comparatively to the rest of?
Yeah, I think I probably took a little trial and error to get the hook to the right point on the graph, because they're taking the graph and translating a bit to hook onto the body. And you can see, if you look closely, you can see it's a little bit off. Yeah, so although it might be better for different scaling factors, but yeah. So yeah, with enough time, you can create all sorts of crazy things. Okay. I'm curious, what if think of one of your functions in the picture I showed. I just do absolute value. not a very interesting function. Basically, it's going to be flapping his arms up and down. Perfectly straight. So, that is something where when they're straight, it matches up perfectly with the. Oh, but it also has a body swaying back and forth.
Yes.
Yeah. So that just involved translation of the x coordinates with positive or negative scaling factors to make it go back and forth, and the same for the eyes. Yeah. Okay, so I guess I had too much time on my hands back then. But okay. Any other questions? I'm glad I remembered to start recording before this anyway. Okay. Any questions about graphics before we move on to other things? I'll look back here.
Hey, Professor, can you hear me?
Yes.
So I have a related and somewhat unrelated question.
Okay.
So I'm working in MATLAB for something for my projects and design for my program, and I was trying to create a 3D plot that used the variables salinity, temperature, and depth.
Yep.
And then it yielded this sound speed as it propagates in water. So I wanted to display 3 different dimensions.
Okay.
And then also the magnitude of the result.
Okay.
And I tried using like the scatter 3, like the 3-dimensional scatter plot, in the MATLAB variety of 3-dimensional plots. And it was just kind of, I could not figure out a function that would accept my input arguments.
Oh.
I didn't know if you had anything in mind that I could use. I tried contour 3, scatter 3. I didn't know if you had anything in mind for that.
Okay, so all right. So basically, you have a function of 3 variables.
Yes.
Okay.
Yeah, I took an equation, just took the total derivative of it to see how sensitive it was to changes in salinity, temperature, and depth.
Okay. And your output variable, what does that represent again?
The output variable is the sound speed.
Okay.
I don't know if you just had anything up your sleeve that you could kind of throw my way, because I just could not think of anything to get it to work.
Okay, so basically you were getting like error messages and such, or you're saying it wouldn't accept your data?
Yeah, like it just wouldn't accept it. It said the matrix dimensions had to agree, which they did, and then they were like, this doesn't take your input arguments, which it should have. I just didn't know if you had anything in mind.
Not on the top of my head anyway. And then you're using scatter 3?
Yeah, I used scatter 3, that first one, with X, Y, Z, S, and C.
Yeah. Oh. Oh, so I was thinking vectors. But you had it as matrices?
Yes, I did I created a capital XYZ out of 3 separate vectors, X, Y, and Z. I just kind of did like the mesh grid function of that.
Right.
It accepts, I think it wants a 2-dimensional input, but I don't know why it would not accept the 3-dimensional matrices.
Oh, okay. So apparently, whatever the vectors that you fed to mesh grid is one of the ones here.
Hmm.
Did you try that?
Yeah, I tried feeding it both the like 2-dimensional vectors and then the 3-dimensional
Oh,
matrices,
yeah,
and I don't know. I just couldn't figure it out.
yeah. You're welcome to send me your code. I can take a look
Absolutely.
at that. Yeah. Okay.
Okay, thanks for taking the question.
Okay. Any other graphics questions? Okay. Actually, this is a good time for